Hi, this is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, we are going to discuss about the topic waveguides. So, this waveguide topic is the topic comes under the unit one, that is microwave passive devices. So, first thing, what is waveguide? So, waveguide is nothing but of microwaves propagates through microwave circuits, components, and devices which act as a part of microwave transmission lines, broadly called as waveguides. So, we discussed so many components and what is microwaves and what is microwave circuit in the previous sessions. So, in all those things, the microwave travels from uh, block to another block, which needs the some transmission line. The transmission line here it is called as a waveguide. Yeah, so the waveguide actually how it will be looking like means it's a hollow metallic tube of uniform cross section of transmitting electromagnetic waves by successive reflections from the inner walls of the tube is called as a waveguide. So this is the statement for waveguide. So when it is asked for a 2 mark question, you have to write this statement. So the following figure shows an example of a waveguide. So you can see this is the waveguide. So port 1 and port 2. You consider the port 1 is input port and the port 2 is output port. So from port 1 to port 2, the power, the signal which needs to propagate from one port to another port, that needs a transmission line. So here this rectangular box this is actually considered as a waveguide where the port to from the port 1 to port 2 the transmission takes place. So it could be considered as a waveguide. So this is a typical example for a two-port rectangular waveguide. Since it has a port 1 and port 2, it is called as a two-port rectangular waveguide. And a waveguide is generally preferred in microwave communications. Waveguide is a special form of transmission line, which is a hollow metal tube. Unlike a transmission line, a waveguide has no center conductor. The main characteristics of a waveguide are a tube wall provides distributed inductance. The empty space between the tube wall provides distributed capacitance. These are bulky and expensive. So let's take up the classroom activity. So here I have shown the some rebus puzzle in this slide. So totally we have 16 questions in this slide. You just team up with your group members and discuss and find out the appropriate answer for this rebus puzzle. Okay. Let's continue the session. So next, what is the advantage of waveguide? That is very very important because knowing about the waveguide and the operation, apart from this advantage is very very important, right? So waveguides are easy to manufacture. They can handle very large power in kilowatts, in the range of kilowatts. So power loss is very negligible in waveguides. They offer very low noise, low value of alpha attenuation. When a microwave energy travels through a waveguide, it experiences a lower losses than a coaxial cable. So what are the types of waveguides? So it has several types. So starting from rectangular waveguide, then second circular waveguide, third one elliptical waveguide, then single ridged waveguide, then next one is a double ridged waveguide. So what are the things we have discussed in the previous slide? There is a type of waveguide. The actual, the physical look of the each waveguide is shown in this slide. So first thing is rectangular waveguide. So this is the actual real-time there is appearance of the rectangular waveguide and the circular waveguide. This one and the elliptical waveguide is shown here and double ridged and single ridged waveguide. So these are all the types of waveguides. And we must know, uh, so when the waveguide is considered, we must know what is the difference between transmission line and the waveguides. So the differences are listed over here. Here the first difference is transmission line supports TEM wave and waveguide cannot support TEM wave. And all frequencies can pass through. Here, only the frequencies that are greater than cutoff frequency can pass through. Two conductors transmission, one conductor transmission. Reflections are less. A wave travels through reflection from walls of waveguide. It has a characteristics impedance, it has wave impedance. Propagation of waves is according to circuit theory. Propagation of waves is according to field theory. It has a written conductor earth. Written conductor is not required as the body of the waveguide acts as a earth. Bandwidth is not limited. Here bandwidth is limited. Waves do not disperse, waves get dispersed. So finally, the assessment. So the first question, what is waveguide? And the second question, draw the two-port rectangular waveguide. Third one, list the advantages of waveguides. Fourth one, list the applications of waveguides. And write the difference between transmission lines and waveguides. Thank you.